Hello, my name is Doug Nunn, and I am doing a presentation today for the Sierra Club Redwood Chapter Climate and Energy Forum. Today's report is a climate report and also on aspects of drawdown. So let's take it away. Here we are. This is Mother Earth. We are 93 million miles from the sun. We are living in what they call the Goldilocks zone. That is, it's not too hot like Venus. It's not too cold like Mars. We actually live in on a beautiful little planet. This picture here was taken from the Apollo 17 mission with the crew traveling toward the moon in December of 1972. I challenge anyone to find a more beautiful planet in our solar system. Some people say Saturn, it's got the rings. No way. Cold as an icebox. I take Earth. So, when I attended Al Gore's Climate Reality Project training in August of last year, he posits three questions. Must we change? Can we change? And will we change? Must we change is the presentation part where he talks about all the difficult things facing our beautiful little planet, pretty much most of them man-made. Here we see a picture of Mother Earth's atmosphere. The atmosphere is reckoned to be around 300 miles thick, but most of that atmosphere is within 10 miles or 16 kilograms of the surface. This is where we get most of the nurturing aspects of the atmosphere. This is also where you see planes fly up, etc. At the edge of that atmosphere, which is probably turning from color to dark completely, is around 28 miles or so. For those of you who saw that movie, The First Man, with Ryan Gosling starring as Neil Armstrong, that's where his X-1 topped out at the top of the atmosphere. We, of course, live on a planet with limited resources. It's a beautiful place, but there's only so much we can use. Let's be mindful. 25,000 miles around our little planet, and it's only about 4,000 miles to the center, to that molten core. Here's some few reminders. Solar radiation comes into our atmosphere. Most of the radiation is absorbed by the Earth. Some of the radiation is radiated back into space in the form of infrared waves, and some of this infrared radiation is trapped by the atmosphere. As the CO2 increases, much of this outgoing infrared radiation is then trapped. The more we increase the CO2 amounts in the atmosphere, the more we build the blanket around us. This is a difficult situation. This is what we are making worse. Over time, there have been lots of periods in Earth history where the atmospheric CO2 has gone up and down, the average global temperature has gone up and down. This has been unrelated to human habitation. It's only in the last years that human beings have affected it. As you can see from this chart, though, we have seen Earth go up and down in temperature and in CO2. The big difference now is that we, Homo sapiens, are dumping 110 million tons of man-made pollution, fossil fuels, warming pollution into the atmosphere every 24 hours. This is a big difference. We began doing this during the Industrial Revolution. This, of course, began at the end of the 18th century. James Watt's invention of the steam engine is one of the beginning points. And at that point, in Britain first, in Great Britain, they began to make factories that had to do with belching smoke into the atmosphere. Britain, of course, was full of coal, and they used coal to run factories at the beginning. Soon the Industrial Revolution has spread to the rest of Europe, especially to Northern Europe, and of course to North America, the United States and Canada. And at the beginning of the 20th century, we saw a new revolution, and this was the manufacture of cars. In 1908, Henry Ford, began producing the Model T. The Model T in 1908 got 21.5 miles per gallon, and there were about 500,000 cars on the road. Last year, on Earth, we produced 70 million automobiles. Unfortunately, the mileage isn't that much better. Of course, in other countries, it's a bit better than it is in the United States. But the average mileage in the United States is still around 25 miles per gallon. And what we have is a situation now where carbon dioxide is being released into the atmosphere faster than at any time in the last 66 million years. For those of you who remember your dinosaur history, it was 66 million years ago that that big meteor hit our planet down on the Yucatan Peninsula, blasted a bunch of pollution into the atmosphere, and darkened our little planet. That's the last time there was this much CO2 in the atmosphere. Here we see a graphic, a little animation of the big sources of greenhouse gases. A lot of these you know, industrial processes, coal plants, industrial agriculture, and we also know, being Northern Californians, of the power of burning forests to put smoke into the atmosphere. The last couple of autumns here in California have been downright brutal in the amount of smoke into the atmosphere. So these are all greenhouse gases. We also know that the population of our planet has gone up repeatedly in the last years. When we see the first time around there was about 1 billion human beings was at the beginning of the 19th century, 1804. We passed 2 billion in the 1920s. I was born in 1952. They guesstimate that the population of the planet was about 2.3 billion people in 1950. So, in my little lifetime of 67 years, it is now at 7.5 billion. The population of our planet has more than tripled. We are a very successful species. Unfortunately, we might be a very dangerous one. This is a classic graph. This is the largest, this shows the largest source of global warming pollution is the burning of fossil fuels. If you look on the left side, around 1850, we were beginning to industrialize. We had had 50 years of it. Europe and North America were industrializing, but look where it picks up. This is the famous hockey stick graph. It's shaped like a hockey stick. And notice the ascendancy of fossil fuels in the last century. They have gone up in a whopping way. Also, we see that global surface temperatures from 1880 to the present have moved in an upright direction. The slope is up and to the right. Please note that at the end of the 19th century, it was fairly cool. You can see all the blue bars down there. But by the 1950s or so, we start to ascend in one direction. By the 1980s and to the present, it's basically gone off the charts and in a rightward direction. And we also know, parenthetical evidence here, but it's true, about 16 of the 17 hottest years have been since the year 2000. The hottest year ever measured was 2016. I have heard that 2017 was the third hottest year ever measured, 2018 the fourth. But just this year, last month, July, was the hottest month ever recorded on this planet. Let's take a look at this. This is a classic bell jar-shaped curve. We see in the middle here, these are deviations from the mean. Those are average temperatures, and we're using the period 1951 to 1980 to show you what was average. This is the curve right there is from 1951 to 80. There it is. That's the baseline. But 1983 to 93, we see it moving to the right. And suddenly we see extremely hot, which is denoted by the very dark red, sort of maroon color. Those are starting to increase. We go from 1994 to 2004. We are well outside of the bell-shaped curve, and we can see the warmer than average and extremely hot temperatures are booming. And then let's look from 2005 to 2015. If you look there, please note, the whole graph has moved to the right. It's almost as if it's completely gone red. Now, this is another difference. Extreme temperatures way back when, say 1955, represented 0.1%. Now these extreme temperatures are ranked at 14.5% of the total. Also, global ocean heat content. These are temperatures measured down to 300 meters and then all the way down below 2,000 meters. Please note here, these have risen tremendously since 1970 or so, and half of this increase has occurred in the last 20 years. Let's remind ourselves of some of the business about how the hydrological cycle works. Evaporation turns to precipitation, hits us on land, and then the water returns to the sea in terms of rivers, etc. It goes back to the sea. Basic fourth grade science. But what's happening in the last years is they're noticing that downpours, rainstorms, hurricanes, etc. are getting stronger. They are dropping more rain at single storms, etc. This is anecdotal evidence, I admit, but if you took a variety of temperatures and or storm situations over the last 30 years, you would see this. Here is flooding in India. Here is flooding in Africa. The last picture was 2015. This is 2018. There is all kinds of flooding going on, and there is also hurricanes. Warmer oceans lead to more intense hurricanes. This is how the climate crisis is working. Hurricanes are intensifying much more rapidly. Warmer air holds more moisture, leading to heavier downpours. Storm surges are increasing. Notice, remember, it's Hurricane or Superstorm Sandy in New York in 2012. And we're seeing a wavier jet stream holding storms in place longer. This has meant that a lot of hurricanes are drenching areas. Let's take a look at this one. This is Hurricane Harvey. This came about in August of 2017. This is the key, and this is why Hurricane Harvey was such a whopper. It crossed waters in the Gulf of Mexico that were up to 7 degrees Fahrenheit, hotter than normal, down to 200 meters. When it crosses a water mass like this, it picks up power. Also, one of the parts is Hurricane Harvey had phenomenal downpours, up to 5 feet in certain places of water. An area like Houston, which is a petrochemical factory area and also oil refinery area, a lot of these refineries and petrochemical plants were flooded. The end result, of course, is toxic pollution. One thing that we're also seeing, too, is the following. A lot of this extra heat we're seeing in our climate change problems, it develops bigger downpours, but it also pulls moisture more quickly from the soil, causing longer and deeper droughts. There have been droughts in Cape Town, South Africa. There have been droughts in Mongolia. There also was a huge drought over 2 years down in Sao Paulo in Brazil. That's an area of around 20 to 22 million people in southern Brazil. The drought broke last summer, but in a difficult situation. We also know that hotter years typically have more fires. This is the last 45 years of western U.S. fires and temperatures. Once again, watch the slope. The temperatures and the fires go up and down in intensity and in number, but the slope is in one direction. This also shows us something else. They know because the CAL FIRE and also the United States Forest Service sees this. The fire season in the U.S. West is now 105 days longer than it was in 1970. I had a friend who was in the smoke jumpers when I was in college in the early middle 70s. He was busy basically from mid-June to mid-September, and then he would go back to school. Granted, not all the fires were out in mid-September, but the point was it wasn't an emergency for 8 months of the year. We're also seeing a rise in extreme weather catastrophes. This chart gives us number of events on the left covered over years, and these are extreme temps, these are floods and mudslides, and they're storms since 1980. Once again, notice the slope. This is a very difficult graphic to watch, but this is a satellite watching the North Pole, the Arctic Ocean, and all the ice from 1984 to 2016. Let's just watch it. Initially, it seems as if the snow or the ice is increasing, ebbing, and flowing. You don't really notice that much. But as we get further into our century, you notice it's getting smaller. 2016, 1984. It's really evident that there is way less ice in the Arctic than there was in 1984. We see Arctic ice sea extent the last 1,500 years. Granted, the years aren't specified here on the bottom, but what you can notice is the drop-off in sea ice extent in the last multiple decades. This is declining ice mass in Greenland since 2002. We also know that our president has recently talked about buying Greenland. Apparently there's some mega real estate opportunities coming up there. But what we see is there's declining ice in Greenland, which also means that the oceans are getting bigger. This is a classic piece. One of the things about the unfreezing of the North is it also means that the permafrost areas are for the first time unfreezing. This is a video that is wind in Siberia. This is a video of a methane bubble in the north of Siberia. That's a Russian soldier testing it. As you notice, underneath that, it's all methane. And what he's going to do is he's going to kick a hole in it, and if you listen, you can hear the gas come out. Presumably you heard that gas come out. That is a rather devastating thing that's going on all over northern Siberia and northern Canada. Other areas that are at risk from sea level rise are all these giant cities. This is projected in 2070, population at risk in millions of people. Many of these cities are in Asia, some are in Africa, and of course Miami is in the United States. This is something else. We know for Storm Sandy in 2012 that areas of Manhattan flooded. Apparently, there's in the area of $129 billion of New York City real estate now lying in flood zones. The comparable figure in San Francisco is apparently between 75 and 80 billion. Now, with this being a New York City real estate problem and us having a real estate president, you'd think this would be taken account of. Another aspect of flooding, of course, is that areas in the South Pacific and other island nations in the Indian Ocean are having to move their populations. And certain countries with low-level land are having to deal with the reality of what to do. Bangladesh, of course, is a relatively destitute country in South Asia, and these areas are of subsistence farming are being flooded with salt water. This, of course, salting agricultural lands was something the Romans did as a punitive measure against their enemies. They did it to the Carthaginians at the end of the Third Punic War. Now, sadly, we're doing it to ourselves. Of course, there are lots of reputable agencies warning us about what's going on and telling us to make a difference here. And what's going on, of course, people like the U.S. Department of Defense are telling us, reminding us we've got to get on it. There are also warnings from areas in agriculture. We see here that David Lobel of Stanford University is warning about sensitive crops and heat and how that is changing. Here is one conjecture from projected yield declines for each 1 degree Celsius of warming in maize or corn, wheat, rice, and soy. Be mindful, these 4 crops make up 2/3 of human caloric intake. They're all in distress. And we're in a situation now, let's take a look at one country. In Syria, which of course is now enduring a terrible civil war, between 2006 and 2010, drought turned 60% of Syria's fertile land into desert and drove 1.5 million people into Syria's already crowded cities. The following spring of 2011, was the beginning of the Arab Spring and Syria's civil war. Suddenly you have a climate-related problem. It also has driven thousands and thousands of people north into Europe. And we also know that climate change is a medical emergency. Let's take a look at these tropical diseases now on the move north and south out of the tropics. West Nile virus, Rift Valley fever, chikungunya, dengue fever, Zika virus. All of these areas, all of these diseases are native to the tropics, and they're now on the move. It also is affecting the way that mosquitoes operate. I don't know about you, but I'm not a big friend of the mosquito, and more mosquitoes are moving. They are moving to the locations where it's more mosquito friendly, where they're able to be more active and reproduce in warmer climates. Their reproduction rates are increases and more generations are being born. Their metabolism is accelerating. They're biting more often. That's news for anybody, whether you're a right-wing politician or not. The virus incubates more quickly inside the mosquito, increasing the time available for transmission. We're also seeing spreading of ticks into Canada, now into Quebec. It's spreading around. There's also the Lone Star tick, whose bite can cause an allergy to red meat and dairy products. This tick can single-handedly put an end to the burger and a milkshake meal that's been so popular for so long. These are expanding too. And ultimately, what we're seeing is a lot of animals are retreating or having to move in relation to how their habitat is changing. The Arctic fox, a white fox, its habitat is shrinking as the red fox's habitat is increasing northward. A lot of animals and even plants are moving. What this is leading to, and the UN gave us a further warning of this the last month, we're now in danger of losing 50% of all land-based species in this century. I let this slide speak for itself because oftentimes it has been told to us over the years, we can't do anything about it. What about the economy? Well, let's remind ourselves that the economy is actually in bad shape because of climate change. This slide, which is put out by the Climate Reality Project, Al Gore's group, gives us all the losses that are happening due to climate change. And this is a very difficult situation. So the question that becomes, can we change? What are we doing to make things better? Well, it turns out there's quite a bit. Is there any precedent technology? What can we do in the area of alternative fuels? Well, let's take a look at what happened with cell phones. Back in 1980, AT&T commissioned a study, and they projected 900,000 users by 2000. The actual figure was 109 million, 120 times higher. And as I do this presentation in various schools, I always ask the kids, who here does not have a cell phone? I never see a hand go up. There are now 8.5 billion cell phone connections in the world. So rapid technologies can come fast. The cost dropped sharply, the quality improved dramatically, and low-income nations with no landline grids leapfrogged the old technology. And there are precedents for us doing something as a world, as a group of United Nations, to deal with difficult environmental problems. Back in the late 80s, we knew that we were getting holes in both ozones at the top and bottom of the world, North and South poles. So, within a year, we put together the Montreal Agreement, which laid down rules for the phasing out and the production of the use of CFCs, chlorofluorocarbons. This was the whole world getting together. We can make a difference. We can do something about these things. Now, here's the trick. As we notice, we have a major challenge ahead of us. And I got this from Linda Brown's presentation on fossil fuels from the Sierra Club. We see that fossil fuel consumption is going up and has been going up even in the last years. We have challenges ahead of us, but we have solutions at hand. This is a wonderful thing to remind yourself. I say this is what I have around for my crabby uncles on Thanksgiving. When they start arguing about climate change, I remind them of this. Enough solar energy reaches Earth every day to fill all the world's energy needs for a full year. Granted, we have not yet mastered how to do this. We have not yet engineered it. But once we do, we're going to be in superb shape. This is a good situation for us. And then, if we compare projections from just 18, 19 years ago, they projected that wind capacity would only reach 30 gigawatts by 2010. We beat that by more than 16 times by 2016. This graph shows global wind energy capacity since 1980. Notice it's still the same kind of curve as we saw previously in the fossil fuel spewing. This, of course, is positive. Wind capacity has increased rapidly in megawatts, especially since the mid-90s. And, like the one about enough sun falling on the earth every day, we do know that there's enough capacity for wind to give us 40 times what we need. One aspect of it is to consider the prairie states of the United States. Kansas, North Dakota, and Texas together get enough wind power to power the whole country. We have great potential. The prairie states of the United States are the Saudi Arabia of wind. Here we see in Europe. Europe has made a masterful amount of additions in wind power. Wind power supplied 43% of Denmark's electricity in 2017. The Portuguese are using it. The Germans are using it. And in solar energy, these have also boomed in the last years. Solar energy has boomed. The solar energy market was said to grow by 1 gigawatt by 2010. By 2016, we had exceeded that by a factor of 75. And world solar photovoltaic installations have boomed. Look at this since 2004. It's off the charts. We are now in a situation where we're actually making a difference, and the amount of solar energy has gone way up. So this is a consideration. We still have a lot of fossil fuel to replace, but we're starting to get to the point where we might be able to do it. Here's some basics. The price of solar has declined 53% in California over the past 5 years. Solar jobs are growing 9 times faster than the overall economy. This in spite of the fact that the Trump administration has done nothing to help. Something else to be considered. If you've got a teenage kid, talk to them about being a solar installer or wind turbine service technician. As you can see, the 2 fastest growing jobs in the country over the next decade. And something else. When they talk about saving coal jobs, or at least the Trump administration does, be mindful. There are 4.7 times as many jobs in solar as in coal mining. And why use yesterday's dirty technology when you can use tomorrow's clean technology? California 12% of its electricity from solar, and we have the potential in this warm, hot state to generate 36 times our total electricity consumption from solar alone. Meanwhile, in places like Africa, there are people who are completely off the grid who are now using solar panels to power little houses. This means all kinds of stuff. It means that your kid can have a light to do homework by. It means that your kid can go to school. Take a look at this. This is from Sierra Leone. Notice these kids have little solar panels powering small computers. A couple of years ago, this would have been impossible, but now it's making a difference in kids' lives. Notice this, renewable energy in India. What was perceived to be the situation in 2013, but now it's being looked at or projected by 2022. India, of course, is trying to phase out coal. Their economy is expanding, so they've been building more coal. But it's making a difference for them in terms of where they're headed to see solar on the horizon. And what also is improving is battery technology. We see this here. This is in the United States energy storage market. We've seen it begin to pick up in 2015. What's projected by 2021 is phenomenal. These are in all sectors: utility, non-residential, and residential. And, of course, the LED light. These are becoming cheaper every day. It is 89% more efficient than an incandescent light bulb. It uses 9 watts compared to 60. It's a big savings. These are LED lights as a percentage of the market. By 2025, they're expected to have over 90%. There are all kinds of auto manufacturings moving to electric vehicles. These are in production or in research. These are completely for the future. This will make a huge difference. Here's some differences too. The cost of clean technologies in the upcoming era. We see that a variety of them are going down in price. You can see this right here. This is all the different ones that are going down. Wind capacity, residential utilities, all kinds of them are going down in price. This has been since 2008. Also, in the United States, what is being built most? We still have a lot of natural gas online. There are other renewables here, but solar and wind are now in the majority of new electrical capacity. And money talks loudly. Here we see the Kentucky Coal Mining Museum in Benham, Kentucky. How do they power themselves? As we can see from their roof, they power themselves with a solar array that saves between $8,000 and $10,000 per year in energy costs. Money talks. Also, as we saw earlier with the Defense Department warning us, we're also seeing banks talking reality here. This is Deutsche Bank. We believe the trend is clear. Grid parity without subsidies is already here. Increasing parity will occur, and solar penetration rates are set to ramp up worldwide. Deutsche Bank. So, what are the things that are being looked at in the future? We want to take a moment here to talk about Drawdown. What are some of the technologies we can be looking at that will help us alleviate some of our problems? I recommend this book, Drawdown. It's edited by a guy named Paul Hawken. Very impressive amount of work has gone into this. So let's take a look at some of the drawdown technologies that are happening. For one, this is not a technology. This is just a reality. We probably have to move to a more plant-rich diet. Agriculture, large-scale beef farm, cattle farms, etc., are very difficult for the planet. We basically need to remember Michael Pollan's admonition, eat food, not too much, mostly plants. Raising livestock presently accounts for 15% of all global greenhouse gases emitted each year. If cattle were their own nation, they would be the third largest emitter of greenhouse gases. So, there is a 2016 study from Oxford University which modeled the climate, health, and economic benefits of a worldwide transition to plant-based diets. Adopting a vegan diet would result in nearly 70% in business-as-usual emissions. It would be a drop. A vegetarian diet would drop 63% reduction. So, these would make a huge difference. They also predict, this study predicts that cuts in health care and costs and lost productivity would be about $1 trillion. They're talking about ocean farming. In this one, there's anchor crops, which are seaweed and shellfish. Scientists have calculated that a global network of sea vegetable farms totaling 70,000 square miles, roughly the size of Washington State, could provide enough protein for the entire world population. We obviously have to be respectful of our oceans to do this. This is another aspect of it. This is called vertical farming, ocean farming. Please note, oysters are great at filtering nitrogen, which would be used. Seaweed farming does not require fertilizers, forest clearing, or heavy use of fuel burning. Ocean farming offers a way out of the pollution cycle. There's also talk of marine permaculture, with kelp and phytoplankton growing much faster than trees or bamboo, and the ocean stores 55 times as much carbon as is stored in the entire atmosphere. In the last years, we've also founded a lot of marine protection areas, and there's some off the coast here in Northern California. And what they do is when they have a protected area, plants and animals increase in volume and in productivity. The plants and animals, let's say fish, codfish or whatever, it starts to spill out into the surrounding area. and that increases the amount of animal and plant life there too. So MPAs are great for the future. There's also talk of using microbes to reduce the need for synthetic fertilizers, pesticides, and herbicides. At present, converting nitrogen to ammonia requires 1.2% of the world's energy use. Presently, a lot of the nitrogen ends up in the sky as nitrous oxides. There's talk of using microbial fertilizers. Here we also see, imagine a farmer driving to a local fertilizer store in a pickup, leaving with a 10-pound bag of nitrogen-fixing bacteria that can fertilize 150 acres of wheat by making bioavailable nitrogen from thin air. This may be some of the future of microbial farming. There's also industrial hemp, replacing cotton. Presently, cotton is the dirtiest crop in the world with respect to chemical use, and is hugely dependent on fossil fuel inputs. It's cultivated on 2.5% of all cropland, but it accounts for 16% of all insecticide use. Hemp is completely different. Hemp may not be as soft as cotton, but it could replace half of cotton's uses. Jeans, jackets, canvas, shoes. It would have a significant impact on carbon emissions. They're also talking about things like pasture cropping. This is growing annuals and perennials together and interspersing livestock with it. There's also talk of multi-strat forestry. Be mindful, I'm not a farmer. I'm just giving you the news from Drawdown. So please take this, go and do more research. Multi-strata agroforestry blends an overstay of taller trees and an understory of one or more layers of crops. So overstory, taller trees, understory, layers of crops. This is apparently better for preventing erosion and flooding, and it can restore degraded lands and soils. There's also the use of biochar. Biochar is the burying of organic waste which eventually turns into usable fertilizer in the soil. It combines the power of sequestration and with that of fertilization. This goes back to a lot of Amazonian tribes who did their own biochar in the pre-European era. We're also talking about reclaiming forests. This is a difficult situation. In the pre-Jair Bolsonaro days in Brazil, they were cutting tree losses by 80%. This is from 2004 to 2016. And this helped a lot with carbon reclamation. The Amazon was doing well before Bolsonaro. But now we're in a difficult situation. He got elected at the end of 2018. This progress is imperiled. The world, of course, desperately needs the Amazon forest. It needs the Congo forests. It needs the North American forests. And they all help with carbon reclamation. We do not have the time for idiots to be destroying our forests. Ultimately, we could more. This is called afforestation. This is when they go out of their way to plant forests and to rebuild areas. Degraded pasture and agricultural lands, corrupted from uses like mining, they're ripe for strategic planting of trees and for making perennial biomass. We can reclaim damaged lands. Don't give it up. Restore, replant, replenish. Let's think of the 19th century as perhaps one of the more difficult times in the terms of ecology. One of the dominant storylines of the 19th century was the vast loss of forest land. But there's no reason we can't replant these areas and begin now. The story of the 21st century could be rewilding of the forests. And there's all kinds of other work. This next part of the slideshow will be a little bit different in the sense that these are artificial. But let's take a look at them anyway. This is an artificial leaf model, and this may allow us to overcome a lot of the horrible mistakes we've made and to have leaf farms that actually eat CO2. Now, I don't know how to do this. I'm just showing you this, so think of it that way. But scientists have managed to successfully create energy-dense fuels by combining solar energy, water, and carbon dioxide. This is the model for an artificial leaf. The makers of those artificial leaves, the inventors, have this is Daniel Nocera and a woman named Pamela Silver. have given you the result, which is inexpensive energy made with sunshine and water and bacteria. Of course, inevitably, we have to make sure we're good at recycling. There has been a difficult problem in the last years in that this year, China has said we will no longer take all your recycling. As you probably know, we've been sending most of our recycling back to China on those container ships that they send products over on. Well, that has changed. China is no longer taking it. This is calling for a massive change in recycling in this country and other industrialized nations. We have to find ways to get back at what we're good at. This means recycling paper, this means recycling plastic, metals, etc. We have a lot of work to do with this one. Recycling needs a revolution. And of course, we have to clean up the oceans. We've turned them into a plastic cesspool. This, of course, is Boyan Schlatt. Boyan is a Dutchman who's about 24 years old now. He, of course, had the dream of cleaning up the North Pacific Gyre with his little boats that are sort of goofy little manta ray type boats. He came up with the idea as a 17-year-old, and he began raising money on crowdsourcing fund sites. Needless to say, no government has helped him at all. He's still hard at work trying to develop the system that might clean up the North Pacific Gyre. The point is, we have a lot to do on recycling. We have a lot to do on cleanup. But with laws like extended producer responsibility, we can make companies responsible for creating goods that are recyclable and who take them back. They have to manage them post-use. If you produce something, you have to find a way to manage it, to get it back recycled. Be mindful, though, that paper recycling is now the norm in Europe. They have 75% recovery rate. South Korea achieves rates closer to 90%. When that happens, forests are spared and we're not wasting paper. There are all kinds of revolutionary ideas on the forefront in the future. Let's take a look at the future of cars for a few moments. Americans spend $2 trillion per year on car ownership, and cars are used about 4% of the time. Cars are extremely inefficient. A car propels 3,000 pounds of steel, glass, copper, and plastic in order to move 150 pounds, in my case 210 pounds, of human being from place to place. This car is effectively 99% inefficient. Robo-cars just may be the wave of the future. We also waste all kinds of space with parking places. Apparently, there are 700 million parking spots which have been created. This is an area the size of Connecticut. Think about the idea of smart highways, black asphalt, energy. It soaks up sun energy. It's exposed to the elements, including passive solar. Road surfaces are prime for solar generation. The smart highway of the future could incorporate energy harvesting, weather sensors, bioluminescent glowing lanes that absorb sunlight during the day and glow at night. No streetlights would be necessary, and the attendant energy waste would be gone. They've been working on tracks like this in Holland and in China and Japan. This is a robotic Rolls-Royce. Autonomous vehicles means your car will arrive without a driver, congestion and traffic might shrink, and cars will no longer circle the block looking for a parking place. They would pick up other passengers instead. Automobiles and trucks presently account for 20% of all greenhouse gas emissions, and that does not include construction and maintenance of streets, highways, and other infrastructures. When I was a kid, there was no Clean Air Act, and breathing car fumes was part of life. Things have improved. But there will be aspects of the future of driverless cars that will be difficult to adjust to. It will eliminate jobs. No truck drivers, no UPS, FedEx, bus drivers, fewer insurance agents, that might be a good thing, insurance claims adjusters, maybe even better, car salesmen, or traffic reporters on the news. Fewer gas stations, odometers, steering wheels, and fewer body shops. Well, maybe fewer, but robots will still crash. And less car crashes, less road rage, driving tests, getting lost and arguing over maps. The worst traffic jam in Beijing a couple years ago traveled at 2 miles per day. In the end, we might see a return of the bicycle as a dominant form of transportation. This is Copenhagen, reckoned to be the most livable city in the world, in no small part because it's bike-friendly. 30% of Copenhageners ride to work, school, and market on 18 miles of bike lanes. This is a Copenhagen bike route pointing the way, moving around the area. Quite a beautiful little place. And what are other aspects of the future we have to work on? We have to work on making sure we educate all of humanity. That means tapping into the fact that we do such a poor job of educating girls. With girls being educated on a regular basis, we tap human potential. All parts of the earth all over are making a difference on this. This needs to increase. It's not only the right thing to do, it's the practical thing to do. And let's look at this reality too. If a girl stays in school the entire school time, 12 years, that means for a difference in 4 or 5 children per woman. This is a big difference. This also means that the population will begin ebbing off by the mid-century or so, and beginning to perhaps even decrease by the end of the century. These are some things that women could take into account. Real birth control, real efforts to allow a woman to control her future makes for less population, a fully democratic population, and a better opportunity for us environmentally and otherwise. So, as we come to the end of this, let's take a look. We've seen that Mother Earth is in trouble. We've seen that we're working on various aspects to make a difference, and we've seen that there's a lot of technologies for the future. In my next slideshow, I will talk about the climate realities, the politics of the climate crisis and those realities. But for the meantime, let's think about what could happen for us. Back in 1975, Ernest Callenbach came out with a provocative new book called Ecotopia. The premise was a great one. Sometime in the late 1970s, Northern California, Oregon, and Washington decided to break off from the Union and build a green society called Ecotopia. In the year 1999, a reporter from the leftover U.S. is allowed to report back. It's an absolutely fascinating book. Ladies and gentlemen, what kind of green future do you advocate? What are some of your green dreams? I thank you very much. This concludes our recording for now. I've been Doug Nunn.